I want to talk about how we're going to use the Z-statistic in order to solve a big issue with the normal curve. Now, first off, I'm just imagining a scenario. In my head, I thought of weights of boxes. So you've got these boxes that are being loaded or whatever, and they're approximately normally distributed with a mean of 42 and a standard deviation of 6. So, depending on what they have in them, they can have some variability amongst their weight. But most things weigh around 42, and as we work away, we have less things. Now, I've already written down, here's the mean, 1 deviation away, so I added 6, then I added 6 to get a second deviation. I did that down here as well, subtracted 6 to go down by my deviations, and then I wrote in the percentages that we had seen in an earlier video, the percent that are between 42 and 48, percent between 36 and 42, and so on. And we talked about the fact that this is the empirical rule. And as long as we're talking about values that are a whole standard deviation away, we can do a lot of things. What percentage are between 30 and 48 pounds? Just add those percentages up. What percentage are between 42 and 54? Well, just add those percentages up. The problem is, when I choose a spot that is not a whole standard deviation away. So let's say I was interested in 40 pounds. And I said, I want to know what percentage are less than 40 pounds. Now, what I hope makes sense is that if the standard normal curve has all of these percentages that are kind of locked in place, if we're approximately normal, these red percentages will be true, then intermediate values will also have a standard percentage associated with them. We just need to figure out what that percentage is. And the way we're going to standardize this is the Z-statistic. So if you'll remember, the Z-statistic is the value we're interested in minus the mean divided by the standard deviation. Well, we're interested in 40. So I'm going to put that in here in place. So 40 minus 42 is negative 2 divided by 6 is negative 1/3 or 0.33 repeating. So again, the negative symbolizes that we're below average, and the fact that it's a decimal means we're not even a whole deviation away. The Z is just saying how many deviations away are we. Now, oftentimes, you'll maybe calculate this using a table of values. Let me show you what that looks like. This is the Z-statistic table that's found on the AP statistics exam. So just really quick, if I can kind of zoom in here so we can see it, you'll see we're going to look for a Z-statistic. And the Z-statistic that we find, we're going to get the proportion below. So we can convert it to a percentage, of course, by just multiplying by 100, but we're going to get a proportion. Now, I was interested in a Z-statistic of negative 0.33. So let's just take a look here. You can see we've got negative 0.3 right here. I'm going to just zoom back out a little bit. Up top here, we've got the hundredths places. So here's 0.03 right there. So if you track these two to kind of where they meet, this is negative 0.33. So 0.3707 or 37.07%. Okay, so that's the way we can read this off a table. Now, we also have technology that would do this on a TI-83 calculator, TI-84. And let me show you another example where we use that, because that's going to make life quite a bit easier. Let's say we're interested in over 50. So, of course, that is up here. Here's 50. And we're talking over, so we're going to go up here. Now, just to kind of go back, the table that I showed you always shows the percentage or proportion below. So we would calculate the same way, look it up on our table, but then we'd have to do 100 minus the percentage we got. Okay, our Z-statistic is 50 minus 42 divided by 6. So that's 8 divided by 6, or 1.3, repeating. Now, let's do this on our calculator. All right, so I'm going to hit second, and then the distribution, it's on vars right next to clear. And I'm going to choose normal CDF. That's what we're always going to be picking for this. Now, I have a little nice thing that fills in my, what I need. Now, I calculated my Z-statistic to be 1.33. And you see it says lower bound. That's where I wanted this to start. And if you remember, I had drawn that arrow. I wanted this thing from that Z all the way up. So I'm just going to type in a huge number. And it can just be ridiculously big because I want the area way, way up. Hit enter. Here we are. So 9.2%. Let me show you how we would have done the other one. So if you remember, the Z-statistic was negative 0.33, but I wanted from that Z down. So I'm going to do a big negative number and then negative 0.33. If you remember, we got like 37%. There it is. Now I want to show you one more, which is instead of being, from a number down or a number up, is actually between. So if I said here's 40 and here's 45, what percentage are inside there? Okay, so if I could draw that up, we could kind of shade that. Like what percentage are inside that? Now you could calculate two separate Z-statistics, one for each of your numbers, right? 40 goes there, 45 goes there, and then you could just use those as your lower and upper bound. But I want to show you one other thing our calculator can do that's really slick. So if we go back to that distribution menu, to normal CDF, and we say our lower bound is 40, and our upper bound is 45, and then you see it has a spot in my little kind of fill in the blank, I can say, well, the mean was 42, and the standard deviation was 6. And it figures it out without us even having to calculate the Z-statistics. So 32% are within that. So if you remember how to plug those n values in, goes lower bound, upper bound, mean, deviation, it actually does the calculating for you. So you should practice, calculating the normal or the Z-statistic for sure. It's valuable to know what it means. It is the number of deviations away from the mean. A negative means below average, a positive means above average. But you should also be prepared to use a calculator to find these values, basically to speed up your work. If this video helped you, please like and subscribe for more math help.